All right, so we ended Friday with this slide talking about three different definitions for yield. And I noticed from some of the feedback from last night's assignment, theoretical yield was one of the concepts that we kind of got tripped up on consistently. A lot of the homework questions were asking for theoretical yield, and there wasn't a whole lot of understanding about what that meant. And what we have to understand, theoretical yield is just simply the amount of product that is expected, the amount of product that is supposed to be made. And so if I do a limiting reactant kind of problem, the theoretical yield would be how much product should I expect from this reaction? So if I'm given a limited reactant where I've got two different reactants, I take the reactants, I turn them both into the product that I'm asked for, and the one that gives me the least product is my limiting reactant. That amount of product is the theoretical yield. Actual yield, on the other hand, is when we do the experiment in the lab, how much did we actually get? Now, for a variety of reasons, when we do an experiment in the lab, we usually get less than the theoretical yield. How much less depends on the procedure that we use, the different techniques that are in play, and how efficient the reaction is in the first place. Percent yield is just the relationship between those two. So I take the actual yield, what I got in the experiment, I divide it by the theoretical yield, what I should have got based on the stoichiometry, and I multiply that by 100% to get it to a percentage. So for the remainder of what is still left in chapter 8 here, we're going to focus on doing two different practice problems. Here's the first kind. First kind is this. If 18.2 grams of ammonia is produced by a reaction mixture that contains 6.00 grams of hydrogen and an excess of nitrogen, what is the percent yield for the reaction? Now, in this particular case, I need to kind of highlight what my individual things are that I'm interested in. So this 18.2 grams of ammonia, we are told that it was produced. So that 18.2 grams of ammonia, that's not my theoretical yield. I didn't have to do any calculations to get it. That 18.2 grams, this is my actual yield. So somewhere along the line, somebody did this experiment and they got 18.2 grams of ammonia when they did it. The other key piece of information here has to do with the 6 grams of hydrogen and the excess of nitrogen. Now we can see hydrogen and nitrogen, those are my reactants. Judging by what we talked about on Friday, ordinarily, I'd have to do a limiting reactant kind of calculation to figure out which one was going to give me the theoretical yield. But since I'm told that this one is an excess, what that tells me is that the 6 grams of hydrogen, that's my limiting reactant. So to answer the question about percent yield, I need to do two things. Remember, percent yield is actual yield over theoretical yield times 100%. I have the actual yield, 18.2 grams. What I don't have yet is the theoretical. Theoretical yield I get by calculating the limiting reactant and turning it into product. Since the question has identified the limiting reactant for me, I just need to do the process of converting it to product to figure out what the bottom half of this equation is. So I need to start with my 6 grams of hydrogen. So I'm going from 6 grams of hydrogen to an unknown number of grams of ammonia. Following out the mapping process, I'm going to turn that grams into moles. I'm going to turn the moles of hydrogen into moles of ammonia. I'm going to turn the moles of ammonia into grams. Now, luckily for us, we've already been given the molar masses, so we don't have to take any time figuring out what those are. So my first step is to turn the grams of hydrogen into moles. For that, I need a molar mass. Ordinarily, I would need to go to the periodic table to do that. However, since it's been given to us, 1 mole of hydrogen is 2.016 grams of hydrogen. My grams cancel. My second task would be to turn the moles of hydrogen into moles of ammonia. For that, I would use the balanced chemical equation. So 3 from the hydrogen, 2 from the ammonia. And then finally, I'm going to turn my moles of ammonia into grams. Molar mass was given to us up here, 17.03 grams in 1 mole. I go back, I see my moles of hydrogen can cancel, my moles of ammonia can cancel. I'm left with just grams. Now, at the end of this process, the grams that I get are going to be my theoretical yield. So 6.00 times 2 times 17.03 divided by 2.016 divided by 3. I get 33.8 grams of ammonia. And so that is my theoretical yield, Ty. Now that I have my actual yield and my theoretical yield, I can solve for percent yield. So my actual yield was 18.2 grams. My theoretical yield is 33.8 grams. Multiply by 100%. Grams of ammonia cancel. So all that's left is percent. 18.2 divided by 33.8 multiplied by 100 to 3 significant figures, 53.8%. So this is the process that you have to go through to get to answering a question like percent yield. You have to have an actual yield, you have to have a theoretical yield. Actual yield comes from the experiment itself. If you didn't do the experiment yourself, it's going to be hidden somewhere in the problem. Theoretical yield comes as a result of calculations, or geometry calculations to be specific. Take the two and put them together, that's going to give you your percent yield. But you have to have both components. You can't just have the one or the other. Right? Questions with this example problem? All right. I'm going to open it up to you here then. Same kind of question. 63.1 grams of hydrogen chloride are reacted with excess oxygen. The reaction produces 49.3 grams of chlorine. Two parts to this question. First of all, we need to determine the theoretical yield, which means we've got to do some stoichiometry. Second thing, once we know the theoretical yield, can we calculate that percent yield? So I'm going to ask you to work on those two things. While you do that, I'm going to pass back some stuff I've been holding for a while that I just keep forgetting to give back to you. And we'll come back and talk about this in a couple of minutes. So get out some paper and start trying to work through this problem. All right, let's go ahead and figure this out. So the thing that we have to focus on here is we have two pieces of information that are both really important. So first of all, we are told that we have 63.1 grams of HCl that are reacted with the excess oxygen. The fact that we are told that this oxygen is excess should right away tell us that this is the excess reagent and that this is the limiting reactant. And so because of this, and this is really important, what that does is that for establishing number one, trying to figure out the theoretical yield of the chlorine, we know that we're going to start with the 63.1 grams of HCl because that is going to be that's the starting value. That's my theoretical limiting reactant here. And so starting with my 63.1 grams, I know that I'm going to turn this into some amount of chlorine. I need to follow my mole map here, turn this into moles, turn my moles of HCl into moles of chlorine, and then my moles of chlorine into grams. Now, in this particular exercise, we didn't give you the calculation. We didn't give you the molar masses. So we're going to have to find them ourselves here. So first step, I need to turn grams of HCl into moles. For that, I need the molar mass. Molar mass of hydrogen is 1.01. The molar mass of chlorine is 35.45. So total mass here, 36.46. My grams of HCl cancel out. Second step, my moles of HCl need to be converted into moles of chlorine. For that, I'm going to need to use the balanced chemical equation, and I need the coefficients. So I need the 4 from the HCl and the 2 from the chlorine. That's going to cancel out my moles of HCl. And then finally, I need to turn the moles of chlorine into grams. And so again, for that, I need the molar mass. The molar mass comes from the periodic table. Chlorine is 35.45, and there are 2 of those. So total there is 70.90. And again, my moles of chlorine will cancel out there. So if I do the calculation all the way through, 63.1 multiplied by 2 multiplied by 70.9 divided by 36.46 divided by 4 to 3 significant figures, because I started with 3 here, I get 61.4 grams of chlorine. So that is my theoretical yield, 61.4 grams. Now to turn this into a percent yield, I have to remember my percent yield is percent is equal to actual over theoretical times 100%. Now the actual yield comes from one of 2 places. Either it's going to be given to us, which is the case here. The actual yield would be the reaction produces. So this is the 49.3 grams. The only other place to get actual yield would be if you were doing the experiment yourself. If you're doing the experiment yourself, you would end up using the yield, the amount that you measure out, that you weigh out at the end of the experiment to figure out this value. But we have that already, so we're good. Theoretical is what we just calculated, 61.4 grams of chlorine. We're going to take this times 100%. So my percent yield is going to be the result of this calculation, 49.3 divided by 61.4 divided by, or excuse me, multiplied by 100 to 3 sig figs again, because I've got 3 in the numerator and the denominator. It's 80.3%. Now, just a couple of things to think about as you're kind of trapping on this concept overall. 80.3%, your percent yield overall should almost always be less than 100%. In fact, it should always be less than 100%, because law of conservation of mass says that 100% is the maximum value. Generally speaking, we run into problems with process or side reactions, the reaction not going fully to completion, purity, lots of things bring our percent yields down. The only way that we would have a percent yield above 100% is if we did something wrong, meaning we perhaps took the wrong value and calculated with it. So if, for example, you used this 63.1 grams of HCl as your actual yield instead of the 49.3 grams of chlorine, that would be a mistake. That would be something that you would do, and it would be incorrect. Otherwise, it usually has to do with experimental kinds of things. You know, you do a reaction where you collect something in water and you filter it, and you're supposed to dry it, but you don't dry it long enough, and you end up weighing water with your solid product, and the percent yield comes up as in, you know, over 100%, and you go, okay, well, that can't happen, so what did I do wrong? So that's really the only kind of scenario where we would see something like that. Generally speaking, otherwise, our percent yield should be less than 100%. And if we can take that with us, we're in really good shape. And so this closes out for us what we need to know out of chapter 8.
And so just looking ahead to the quiz at the end of this week, the majority of the questions on the quiz are going to be focusing on limiting reactants and percent yield kinds of questions. That's going to be what you're going to see primarily in that quiz. There might be a little bit of information from Wednesday's lecture when we start looking at some maybe some electron configuration stuff, but it's going to be very minor. The bulk of that quiz is going to be on this stuff. So make sure that you prepare accordingly. And so with that, we're going to close out this particular lecture. And I'm going to open up for you to get your final little bits of feedback in here before we call it a day with this. And then we'll go into just taking a sneak peek into chapter 9 to close out today.